1.7, midpoint and distance in the coordinate plane. This is an extremely important section. We are going to use these ideas in every chapter. The key word here is coordinate plane. Anytime you see that, you know that we are going to be dealing with the midpoint of a segment and the distance between 2 points in the coordinate plane. We have some formulas here. Our first formula is when we're doing a number line. So on a number line, we are talking about vertical or horizontal components. Your vertical components, this would be your y-axis. Your horizontal components are your x-axis, right? Back and forth. So on a number line, the coordinate, so we're talking about a point, the coordinate of the midpoint is the average or the mean of the coordinates of your endpoints. So we have a formula. The midpoint is a plus b over 2. And this is a good formula to know. This is also in your big packet. So we have 2 points, point A at coordinate A, point B at coordinate B. We simply add those two together and divide by 2. That gives us the average. Now in a coordinate plane, okay, we are talking about lines on a diagonal. All right. The coordinates of your midpoint are the average, it's just a midpoint, midpoint's always in the middle, the average of the two, halfway between the two, the average of the x-coordinate and the average of the y-coordinate. So you can see here that once again we are going to be labeling our points x1, y1 and x2, y2. Anytime you are dealing with a coordinate plane, you're going to have 2 points and you are going to label them x1, y1, x2, y2. And you notice here we have a formula for the midpoint. This formula is exactly what we just did. It's just this is the midpoint of your x coordinates. This is the midpoint of your y coordinates. So we have 2 points, A and B, and we have a segment. We want to find the point that's in the middle of those. So what we're going to do is our x-coordinate goes from here to here. We want the midpoint of our x-axis, and our y-axis goes from here to here. Those are the y points, right? And we find the midpoint of the y-axis, and that is going to give us the xy coordinate of our midpoint. So we're just doing exactly the same thing as we did for a vertical or horizontal line. It's just now we have to do both to find it for a diagonal line. This is for anything that's diagonal. Let's look at an example. Segment AB, remember that's read as segment AB, it's got the bar on the top, has endpoints at -4 and 9. So we look here, A is at -4, B is at 9. We simply write our formula, -4 plus 9, A plus B, divided by 2 is 2.5. The midpoint, M, is here at 2.5. So we can do that on any horizontal or vertical line. Now let's look at it on a diagonal line. If we're on a coordinate plane, segment EF has endpoints at 7, 5, and F is at 2, -4. So we want to find the midpoint. Now we know that that midpoint's going to be right about in there somewhere. Okay. So we label our points and we call them x1, y1, x2, y2, always label your points. And then we use our formula. So we're going to do the x-coordinate first. We add x1 plus x2, divide by 2, and we get 4.5. Then we do our y-coordinates. We do our x-coordinate and our y-coordinate. We take our y values, 5 plus a negative 4, divide by 2, gives us 1/2, or 0.5. So our midpoint is a point at 4.5, 0.5. So let's look at that. 2, 4, 4.5 is there, up 0.5, and that's our midpoint, M, which is right about where we expected it to be. All right, pause the video and do the next problem. All right, so we have 2 points. We label them x1, y1, x2, y2. Order does not matter. So we have segment RS. Our order does not matter as long as one of them's x1, y1, one of them's x2, y2. And then we have our midpoint formula on a coordinate plane. We substitute in our values, and for my x values, I got my x value is 4, my x coordinate is 4, and I substituted in my y values. Watch your negatives. My y coordinate is -2, so the midpoint is 4, -2. And if you want, you can plot that and check it and see if it looks good. So let's see, 5, we'll just plot it on this here, 2, 4, 5, -10 doesn't quite go to -10. 7, 8, 9, 10. Well, if you like, you can plot it and look at it. I'll do that. We'll pause it. All right, I did a quick plot here, and even just by hand, we can see that S is up here, R is down here, and M, 4, -2. That's very much where we expected it to be, so we did a good job. All right. This we are going to mark as a good example. So when you get to the point on your assignment and you go, I don't know how to do these, I'm going to refer you to the good example. All right. We're told that the midpoint of segment CD is at -2, 1. So we know the midpoint. It's at -2, 1. And one endpoint, C, is at -5, 7. We want to know the coordinates of the other endpoint. So we know that D is down here somewhere. ? We follow the exact same rules. It doesn't matter what your rules are. Math is math. So I'm going to label x1, y1, and x2, y2. Right? My endpoints are x1, y1, x2, y2. And my midpoint is just my xy. Right? My formula says that the midpoint, xy, and my marker here, the midpoint that's at xy is equal to x1 plus x2 over 2, y1 plus y2 over 2. So I just substitute in. I know my xy values, so I'm going to find my x value, right? X equals x1 plus x2 over 2. And I simply just do order of operations, follow my math here. I multiply both sides by 2. That cancels. I get -4 equals a -5 plus x2. I add 5 to both sides, and I get x2 equals 1. Should have done that down here. So my x2 value is 1. And then I do the same for y. I substitute in my values. This is my y value. I multiply both sides by 2. That cancels. I get 2 equals 7 plus y2. I subtract 7 from both sides, and I get y2 is negative 5. So this point is at 1, negative 5. And let's look. Over 1, down negative 5. Yeah, that's exactly where we would expect it to be. So go ahead and pause the video and do the next problem. Alright, we were told the midpoint of segment AB has the given coordinates and the endpoint A has given coordinates, and we want to know the coordinates of point B. So I just sketched a line. It doesn't matter where the line is. I don't have to put it on a graph. I just know that point M is between A and B. And I labeled A and I labeled B. And I know that A is x1, y1, and B, I don't know the values, but I know that it's x2, y2. And my midpoint is just x and y to fit with my formula. I wrote out my formula. I found my x coordinate. 4 equals a negative 3 plus x2 over 2, multiplied both sides by 2, and I ended up with my x2 is at 11. And then I did the same thing for my y coordinate. Negative 9 equals negative 5 plus y2 over 2. I multiplied both sides by 2, and I ended up with y2 equals negative 13. So my point B is my x2, y2 value, 11, negative 13. And even though my line is not a diagonal here, I just have any line drawn. I could have drawn it horizontal and it would have worked just as well. I'm looking here, and 4 is between negative 3 and 11. So that's good. And negative 9 is between negative 5 and negative 13. So that's good. I know that I'm in the right place, even without properly graphing it. Okay, so this is a good way to check. Geometry is very visual. We are going to draw lots and lots of pictures and label our diagrams. All right, that's the midpoint formula. Distance formula. In 1.3, we found the distance between 2 points on a number line. That means horizontal and vertical. That means x and y axis. If you have a horizontal line or a vertical line, you can use the distance formula from 1-3. That was the absolute value of the difference. Right? Distance equals the length AB. We should do this properly. A minus B, right? Absolute value of A minus B. If we are on a coordinate plane, as I said, anytime you see the words coordinate plane from now on, which you will every chapter, you immediately think midpoint formula and distance formula. This time we're using 2 points. Again, we label them x1, y1, x2, y2, and here is your new friend, the distance formula. It is the square root of the quantity. Good word, you need to use it. Quantity, that's what the parentheses say. x2 minus x1, that quantity squared, plus y2 minus y1, that quantity squared. So you're going to have to follow order of operations here. We do the stuff in the parentheses first, then square it, our exponent, then we're going to add them together, then we will take the square root. Okay, if you have any knowledge of the Pythagorean theorem, you can see that this is just a right triangle, and a squared plus b squared equals c squared. So if we wanted to find c, the square root of a squared plus b squared would equal c. We square root both sides, and that's simply our distance formula. To find the length of side A here, that length, we use our A minus B. And we don't have to absolute value it because we're squaring it, which is automatically going to make it positive. All right, let's look at an example. What is the distance between point U and point V with the given coordinates? Well, we label them x1, y1, x2, y2, because that's what we do. We write our formula, and we substitute in. Watch your negatives. These formulas are minus, so we have 4 minus, and then the value of x1 is -7. And minus a negative is plus a positive. So this is 4 plus 7 is 11, and minus 3 minus 5 is -8. Then we are going to square those. This is -8 times -8. Negative times negative makes a positive. Make sure if you put it in your calculator that you use your parentheses appropriately. You are squaring -8, not making the negative of 8 squared. So be careful there. So then we get the distance is the square root of 185 in a calculator. This is read length UV. Remember that? We learned that. Length UV is 13.6 units. Like I said, you will label everything properly even if the book does not. All right, go ahead and pause the video and do the next problem. All right, part A says, what is the length of SR? We're given points. We label them x1, y1, x2, y2. We write our formula. We substitute in, being careful of those negatives. It's 3 minus -2. Minus minus is plus plus. So we square 5. We square a -15. Both of those come out positive. So the distance, the length of SR, we could also call this the length SR, is the square root of 250 units, or if we want it in, estimate it in our calculator, 15.8 units. Okay, the second question, question B. If we switch x1, y1, and x2, y2, does it make a difference? No. You're going to get the same result. So yes, you get the same result, because distance is simply the absolute value. How far from one point to the next point. Doesn't matter which direction you go. It's the square in here that makes it positive. Just like when we're doing horizontal and vertical, absolute value makes it positive. All right. So, example problem. We're on a zip line course, and we start from platform A and zip to each of the platforms. It says, how far do you travel from platform B to platform C? So we want to find B and find C. That's the section that we are looking at. We find our values, label them x1, y1, x2, y2, substitute, write our formula, substitute in, do the math, and so it's either, stop that. Length BC is either the square root of 1125, and this is in meters, If you're given a unit, your answer will certainly have a unit, or the length of BC. Put that in your calculator. Nearest tenth. We are asked to the nearest tenth. 33.5 meters. So be the appropriate way to label that. Length BC is 33.5 meters. All right. So pause the video and find the distance from platform D to platform E. Alright, these problems are a little bit tedious, but nothing really difficult here. So we find our point D is at 20, 20, and E is at 30, negative 15. We label them x1, y1, x2, y2, and we write our formula. We substitute in, being very careful of our negatives and our parentheses. And we find that the length of DE, the distance from platform D to platform E, is the square root of 1325 meters, or we put that in our calculator because here it's way more useful as a decimal, 36.4 meters. So we zip line 36.4 meters. Again, you will see these formulas every single chapter. Anytime you see a coordinate plane or the word coordinate plane, or you see the graph up there, you know that you are going to be using the midpoint formula and the distance formula.